Welcome. In this video we are going to investigate what Kirchhoff's voltage law is, how it works, and its application in series and parallel circuits. Gustav Kirchhoff is a German physicist and created this law in 1845 to deal with the behavior of potential difference, or voltage as commonly known, in circuits. Kirchhoff's voltage law states that the algebraic sum of all the voltages around any closed-loop path in a circuit will always be equal to zero. And this is very useful in finding unknown voltages in a closed circuit. A helpful analogy for understanding Kirchhoff's voltage law in circuits is to consider voltage akin to pressurized gas. Meaning particles will attempt to disperse in the evenest way possible, causing higher pressure areas to flow to lower pressure areas, where they are less compressed, and hence in a lower energy state. The difference between these pressure areas being the potential energy of the particles in the system, with potential energy being just another word for voltage. Furthermore, in such an analogy, resistors are akin to valves which limit the flow of particles, and voltage sources are akin to compressors creating higher pressure areas. The pressures of areas are shown graphically by the density of the flowing arrows. Looking at the provided example circuit, it can be seen how in a closed circuit the law for every force there is an equal and opposite reaction becomes very relevant, as all the force generated by the compressor will necessarily need to be opposed by a resistance equal and opposite to it, in the circuit. Hence why the pressure change across a single resistor becomes precisely the same as the compressor except opposing. And from a more abstract system one can intuitively understand this has to be true in any stable closed loop regardless of the resistances. For many components in series it becomes slightly more complicated as the voltage changes over each component in relation to the percentage of the total resistance of the circuit the component makes up multiplied by the applied voltage. Meaning over a series circuit with many resistors in series the voltage drop across each is small, however their sum would still be exactly equal to the applied voltage. In the provided circuit you can see as the resistance is the same for all of them the voltage drop across each is also identical. Finally, for a parallel circuit it is quite straightforward. However, it does highlight why it was necessary to use the word path instead of just saying in the circuit. As for paths in parallel, all of the paths of the exact same voltage. Since despite there being less total resistance in the circuit, each resistor is 100% of their path and hence must have a reactive voltage equal to the applied voltage. However, for advanced circuits the voltage across parallel circuits is found using nodal analysis which merges parallel paths into just one component. Thank you for watching and hope you have learned something about Kirchhoff's voltage law.